Welcome to the DIY Honda Garage channel. Welcome to our detailed troubleshooting guide for DTC P0171, indicating a fuel system 2 lean condition in the 2017 to 2022 Honda CR-V. This error code points to a situation where the air-fuel mixture in the engine is deficient in fuel, resulting in inefficient combustion. The Engine Control Module, ECM, monitors various components, including the mass airflow MAF sensor and the AF air-fuel sensor, to maintain appropriate air-fuel ratios. If readings from these sensors suggest too much air relative to fuel, or if they detect an issue with fuel delivery, you'll see this code. The MAF sensor is typically located in the intake duct near the air filter, and the AF sensor is found in the exhaust manifold. Diagnosing DTC P0171 requires careful inspection of these components, along with others related to the fuel system. DTC P0171 indicates that the engine is experiencing a lean fuel condition, which means that the air-fuel mixture is off balance, containing too much air and not enough fuel. This error primarily involves the fuel system components, particularly the intake side, as they regulate the air entering the engine and the fuel delivered for combustion. Key components include the mass airflow MAF sensor, which measures the amount of air entering the engine, the AF sensor, which helps the Engine Control Module, ECM, determine the optimal air-fuel mixture, and the fuel injectors, which deliver the appropriate fuel volume. The MAF sensor is typically located in the air duct between the air filter and the engine, while the AF sensor is integrated into the exhaust system. If the readings from these sensors deviate from designated thresholds, it may trigger the DTC P0171. There are several common possible causes for DTC P0171. A contaminated MAF sensor can give inaccurate readings, leading the ECM to think less fuel is needed. Inspecting the MAF sensor is crucial, as it often collects debris that interferes with its operation. Additionally, vacuum leaks in hoses or other components can introduce excess air, which again disrupts the air-fuel balance. Fuel delivery issues may arise from a clogged fuel filter, failing fuel pump, or malfunctioning fuel injectors, which may not supply adequate fuel when needed. Each of these potential problems must be examined to determine the source of the lean condition indicated by this DTC. Several symptoms may accompany DTC P0171, signaling that the engine is running in a lean condition. One common symptom is rough engine idle, where the vehicle may feel unsteady when stopped at a light. Decreased fuel economy is another significant symptom, as the lean condition may cause improper combustion, leading to increased fuel consumption. Engine misfires may also occur, particularly under load, as inadequate fuel fails to support engine demands. Lastly, a check engine light illuminating on the dashboard is almost always a direct indication that something requires attention in the vehicle's engine management system, prompting further diagnostics. The first step in troubleshooting DTC P0171 involves verifying the problem by starting the engine and letting it idle without load, either in park or neutral. This initial step is crucial for setting a baseline for the diagnostic process. While the engine is idling, use the Honda Diagnostic System, HDS, to check the parameter failure feedback, AFFB, for short-term fuel trim. This value must exceed the threshold of 1.33 for further diagnostics. If it does, this indicates that the fuel trim at idle is excessively leaning out, justifying the suspicion of an underlying issue. If it's within acceptable limits, proceed to the next step to gather additional data. In the second troubleshooting step, you will review the onboard snapshot data to gather historical performance information. This involves recording the values for engine speed, vehicle speed, relative throttle position, TP sensor, and accelerator pedal position APP sensor when the AF/FB value was at its highest. This data is critical in understanding how the vehicle is operating under various conditions. After recording this information, drive the vehicle under the same conditions to replicate your measured values. While driving, once again, monitor the AF/FB parameter using the HDS. If it remains high, further steps must be taken to pinpoint the source of the overly lean condition. The third troubleshooting step focuses on the mass airflow MAF sensor, which plays a crucial role in determining the engine's air intake volume. First, turn the vehicle off and switch it to the off lock mode. Safely remove the MAF sensor and inspect it for any debris, such as lint, bugs, or other foreign objects that could be obstructing its function. Any interference can yield erroneous readings, leading the engine control module to miscalculate the air-fuel mixture. If debris is found, remove it and use a vacuum cleaner to clean out any remaining contaminants in the air cleaner housing. If the MAF sensor is clean, reinstall it before moving on to step 4. During the fourth troubleshooting step, you'll need to visually inspect critical components associated with the air intake and engine breathability for any signs of damage or disconnects. Focus on key areas, including the crankcase breather hose, air cleaner housing, intake air duct, oil cap, and dipstick. Look for cracks or damages that could cause unwanted air leaks, which would throw off the air-fuel ratio. It's essential to verify that all hoses are securely connected and intact. If you discover any discrepancies, like a disconnected hose, correct them as necessary. If everything appears to be in order, proceed to check the positive crankcase ventilation PCV system in the next step. In this fifth step, let the engine idle and assess the functionality of the positive crankcase ventilation PCV system. To do this, pinch the PCV vacuum hose while monitoring the AF/FB parameter with the Honda Diagnostic System, HDS. The objective is to check if the AF/FB reads more than 1.33. If it does, the PCV system functions correctly and is not leaking, leading you to the next step in your troubleshooting. However, if the AF/FB value does not meet this threshold, it indicates a potential vacuum leak within the PCV system, which would need further investigation of the vacuum hoses and may require necessary repairs. The sixth step involves checking for intake manifold vacuum leaks, which can also cause a lean condition. Start by disconnecting the intake air duct from the air cleaner housing. Then, connect a large intake manifold adapter cone into the duct from the OTC LeakMaster Evaporative Emission System Tester Kit to introduce smoke into the intake manifold. As the smoke flows, inspect critical areas for signs of leaks, such as the intake manifold, gaskets, throttle body, and associated vacuum hoses. These leaks need to be repaired immediately to restore the correct air-fuel mixture. Once all components are checked, reconnect any disconnected parts before proceeding to assess the MAF sensor reading. The seventh troubleshooting step necessitates another idle check of the engine under specific conditions. Ensure that the engine coolant temperature, ECT sensor 1, reads above 158 degrees Fahrenheit, 70 Celsius, and that the transmission is in the park or neutral position, with all electrical loads turned off. Monitor the engine speed using the HDS while holding it at a steady 2,500 RPM for 30 seconds. This part of the procedure is crucial to steady engine dynamics, as it allows you to accurately check the MAF sensor reading. Monitoring the airflow rate through the MAF sensor should fall within the acceptable range of 6.5 to 9.1 grams per second, GS. After 30 seconds, if the reading matches, proceed to check fuel pressure. In the 8th step, it is essential to examine the fuel pressure when the AF/FB reaches 1.33 or higher. This check is critical for establishing whether the fuel delivery system functions adequately under these lean conditions. If fuel pressure is within the specified range during testing, the issue might lie elsewhere, allowing you to move on to the next step. However, if pressure is outside the designated range, ensure that the fuel pump receives proper power supply and grounding. If all connections are correct and the problem persists, it may indicate a need to replace the fuel tank unit as a resolution to the low fuel delivery issue. The 9th troubleshooting step involves evaluating high fuel pressure by conducting a DI fuel pressure test. Begin by turning the vehicle off and switching to the on mode before clearing the DTC with the HDS. Start the engine and maintain a steady engine speed of 3,000 RPM without load until the radiator fan activates, after which you can return to idle. Use the HDS to select the DI fuel pressure test within the inspection menu. Your HDS should indicate whether the high pressure side is normal. If the reading is normal, continue with the next steps. If not, further diagnostics for related DTC P0087 or P0088 are required to address high pressure issues. In the 10th step, if a fuel-related issue is suspected, it's prudent to replace the existing fuel in the tank with known good fuel. It is particularly critical to check this if the lean condition arose shortly after refueling, as the fuel quality may severely impact the air-fuel ratio. Start by turning the vehicle to the off position to drain the fuel tank before refilling it with fresh fuel. Afterward, operate the vehicle under the same conditions where the AF/FB reading was elevated. Monitor the parameters with the HDS during this operation. If the readings continue to reflect AF/FB values exceeding 1.33, further action is warranted. During step 11 of the diagnostics, if the AF/FB value remains problematic after replacing the fuel, the next logical component to inspect is the AF sensor, Sensor 1. Begin the process by turning the vehicle to the off lock mode. Then, replace the faulty AF sensor with a known good component. Follow this by starting the engine and operating the vehicle under similar conditions where the AF/FB value previously spiked. Again, check the AF/FB parameter with the HDS while driving. If it correctly reflects the expected range after replacement, it may indicate the original AF sensor was faulty. If the high value persists, reinstall the original AF sensor and move to the next step. The 12th and final troubleshooting step focuses on the fuel injectors, which may also be contributing to the lean condition indicated by DTC P0171. Firstly, turn the vehicle to the off lock mode before replacing the existing fuel injectors with known good injectors from a reliable source. After the installation, start the engine and operate the vehicle once more under the same conditions previously identified when the AF/FB reading was over 1.33. Check the AF/FB with the HDS while driving, and if the reading aligns correctly, this indicates that the original injectors were likely at fault and needed replacement. If the issue remains unresolved, substituting a known good powertrain control module, PCM, is the next step to investigate. After completing all necessary repairs related to DTC P0171, it's vital to perform a final verification process. Conduct a thorough test drive to simulate typical driving conditions and allow the system to recalibrate itself. During this drive, consistently monitor the AF/FB values using the Honda Diagnostic System, HDS, to verify that they have returned to acceptable limits, indicating a balanced air-fuel mixture. Also, check whether the check engine light remains off throughout the drive which indicates that no fault codes are active. Successfully passing this verification step ensures that previous issues have been adequately addressed before closing the case. Preventive maintenance plays a significant role in avoiding DTC P0171 and associated fuel system issues. Regularly cleaning the mass airflow (MAF) sensor is essential, as debris accumulation can lead to incorrect air readings. Additionally, ensure that you use high-quality fuel and refrain from allowing low-quality or contaminated fuel to enter the tank, as it can affect the entire fuel delivery system. Conduct periodic inspections on all hoses and connections to confirm they are sealed tightly and free from cracks, providing a reliable path for air without introducing leaks. Staying proactive with these maintenance tips goes a long way in ensuring the optimal performance and longevity of your Honda CR-V. In conclusion, we've examined DTC P0171 and the implications of a lean fuel condition in the Honda CR-V manufactured between 2017 and 2022. Understanding the key components, including the MAF sensor, AF sensor, and fuel injectors, is critical in diagnosing the problems that lead to this error code. A reliable step-by-step troubleshooting approach allows you to identify the source of the issue effectively, from initial checks through to potential component replacements. Lastly, implementing preventive measures can help avert similar issues in the future and keep the engine running smoothly without fault codes reappearing. Always ensure comprehensive checks and regular maintenance for the best vehicle performance. Please like and subscribe to the channel. See you next time.